In this video, we'll discuss how to draw Lewis structures, how to identify whether an octet is complete or not, and then when to use single, double, and triple bonds. Remember that you can determine the number of valence electrons by looking at an atom's placement on the periodic table. Main group elements, the group number represents the number of valence electrons with the exception of helium, which only has 2 total. So step 1 in drawing valence electrons for compounds, find the total number of valence electrons. Phosphorus has 5 valence electrons. Chlorine has 7. There are 3 chlorine in this compound, so 7 times 3 plus 5 is 26. Least electronegative atom in the middle, which is phosphorus, because phosphorus is further away from fluorine than chlorine is. Lower electronegativity than chlorine, so phosphorus goes in the middle. Then we surround it by the other atoms. Step 3, place a line. Each line represents a covalent bond between atoms. That's 2 electrons. Phosphorus and chlorine share 2. Each one of these bonds is a sharing of 2 electrons. That means that right now phosphorus has 2 electrons per bond, so that's a total of 6 electrons, and each chlorine has 2 at the moment. Now we need to complete the octet for each atom. Remember, an octet is 8 valence electrons, so complete the octet for each. Make sure that we have 26. We do. So let's see, do we have an octet for each? 8, 8, 8, and then phosphorus also has 8 with a total of 26. So this is complete. Another example, find the total number of valence electrons. Each hydrogen has 1 electron. There's 2 of them, plus 6 valence electrons for oxygen. That gives you a total of 8. Least electronegative atom in the middle. Oh wait, oxygen is not the least electronegative. Hydrogen is, but here's the deal. Hydrogen is an exception. It always goes on the outside no matter what. Form bonds. Complete the octet. The hydrogens can only hold 2 total electrons, so 2, that one's good. 2, this one's good. We just need to do oxygen. Oxygen has 8. We needed a total of 8 electrons. We have 8, and all of our octets are complete, so this is also a finished Lewis structure. Now we have a polyatomic ion, cyanide. Carbon has 4, nitrogen has 5, and then that negative, that's 1 more electron. So we add another electron. 4 plus 5 plus 1 gives us 10. There is no middle atom, so we put them side by side. We draw our line. We complete the octet. Remember, it was a total of 10 electrons, so we'll put 10 in here and see what happens. 2, 4, 6, 8, 10. Good, but guess what? Our octets are not complete. So we're going to do a trick. We're going to use double and or triple bonds to complete the octets. So we take electrons from either atom or both and make a bond out of it. So we just move these electrons to the middle to form a bond. Carbon has a complete octet, but nitrogen does not. Nitrogen only has 6. So we'll take 2 from carbon and see if we can make it work. We have 8 on carbon, we have 8 on nitrogen. We're good to go. Now let's represent an ion with brackets and the correct charge. Okay, that's how you draw Lewis structures for polyatomic ions. You need to use the brackets and the charge. Okay, hopefully that helps.